Hey everyone, and welcome. Today, we're going to crack open the master blueprint for automating everything in Azure. You know that feeling of being bogged down, deploying and managing cloud resources? Well, this explainer is all about showing you how to do it faster, smarter, and with way less hassle. We're about to totally transform how you think about building in the cloud.
So, let me ask you something right off the bat. When you're working in the cloud, do you feel like the architect, the one designing this grand vision, or do you feel more like the bricklayer, down on the ground, manually placing every single resource, one by one by one?
Because let's be honest, clicking through the Azure portal to create stuff is exactly like laying individual bricks. Yeah, it works for one little thing, but it just doesn't scale, right? Today, we're handing you the power to build entire cities in the cloud automatically. No more laying bricks, it's time to become the architect.
Okay, so before we jump into the blueprint itself, let's really dig into why we need it. Let's get right to the heart of the issue, the big nagging problem with all that manual work. And this right here, this just says it all. I mean, sure, clicking to create one single virtual machine, that's easy. But what about when you need 50 of them for a new dev environment? Suddenly, doing it manually is a huge risk. It's just asking for human error, inconsistencies, and a really, really long day. With automation, though, it's not just fast. It's perfectly consistent every single time. So, what's the answer? Well, it's this game-changing idea called infrastructure as code, or IAC. The concept is actually really simple. Instead of clicking around in a portal, you write code. You define everything you need, your servers, your networks, your storage, all in a text file. Then you just hand that file to Azure and it builds everything for you. You are literally coding your infrastructure into existence. And the payoff? Oh, it's huge. It's like going from a horse and buggy to a rocket ship. First, you get flawless consistency. Every environment is an identical twin of the last. Second, you get insane speed. You can deploy super complex systems in minutes instead of days. And finally, and this is a big one, you completely remove human error from the equation. The code just does what you tell it to do, every single time. So if infrastructure as code is the strategy, what's the actual blueprint we use in Azure? Well, the foundation, the bedrock of all of this, is something called an ARM template. I want you to think of it like the super detailed official engineering schematic for your entire cloud setup. So, what is an ARM template? At its core, it's a file written in JSON, and you use it to declaratively define your stuff. Now, declarative is a word you'll hear a lot. All it really means is you state the end result you want. Like, I want a server with these specs, and you let Azure figure out how to make it happen. And they're idempotent. What's that? It's like a light switch. It doesn't matter if you flip the on switch once or 100 times, the light is on. The end state is always the same. No surprises, no accidentally creating 10 copies of something.
Okay, listen up. Especially if you're studying for an Azure exam, this slide is pure gold. An ARM template has 4 key parts you just have to know. First, you have parameters, which are your inputs, like a server name. Then, you've got variables to store reusable values and keep things clean. Resources is the heart of it all. It's the list of what you're actually building. And finally, outputs let you get information back after it's all done, like the new public IP address of a machine.
Now, ARM templates are incredibly powerful. But let's be honest, writing all that JSON, it can be a real headache. It's long, it's complex, and it can be really hard to read. That's exactly why Microsoft created a simpler, much more modern way to write our blueprints. And that's where Bicep comes in. And I mean, the difference is night and day. Just look at this. Where ARM templates can feel like you're drowning in this complicated, messy JSON, Bicep gives you a clean, simple syntax that's just so much easier for us humans to read and write. And what does that mean? A much, much lower learning curve. It makes infrastructure as code accessible to everybody, not just the JSON experts. Okay, this is probably the most important thing to get about Bicep. It is not a replacement for ARM templates. It's just a smarter way to write them. See, behind the scenes, when you deploy a Bicep file, Azure just converts it into a standard ARM JSON template for you. So you get the beautiful simplicity of Bicep with all the battle-tested power of ARM. It's truly the best of both worlds. And just to prove it, take a look at this code. This is literally all it takes to define a storage account in Bicep. See how clean that is? You've got the keyword resource, a name you give it, the official Azure resource type, and then just the properties. You don't need to be a wizard to figure this out. It's just intuitive. So we've got our blueprint written in Bicep. We can now build our city in the cloud. But what about keeping the lights on? You know, the day-to-day stuff. How do we put all those routine, boring, repetitive tasks on complete autopilot?
Well, that is where the magic of Azure Automation comes in. It's a service that's built specifically to automate all those time-consuming management tasks. The classic example everyone uses because it's so powerful is scheduling your dev VMs to shut down at night and start back up in the morning. I mean, think of the money you save. But it can do so much more, patching servers, cleaning up old files, you name it.
So, how do you get started? It really boils down to two key things. First, you create an automation account. Just think of this as your central command center for everything automation. And then inside that account, you create what are called runbooks. These are just the scripts, usually written in PowerShell or Python, that actually contain the instructions to get the job done.
But hang on a second. If a script needs to go and manage other resources, how does it log in? How does it authenticate? Because storing passwords or secret keys directly in your scripts is, well, it's a security nightmare just waiting to happen. The solution is this really elegant thing called a managed identity. Basically, you give your automation account its own identity in Azure, and then Azure handles all the authentication securely behind the scenes. No more secrets in your code, ever.
Okay, wow. We have covered a ton of ground. So let's lock it all in. I'm going to give you a rapid-fire summary of the absolute key takeaways you need to know, especially if you're prepping for an Azure certification exam.
Here's where people get tripped up. First, don't confuse Bicep and ARM. Bicep is just a better language on top of ARM. Second, always use parameters in your templates to make them flexible and reusable. Third, really understand what idempotency means. You're defining a final state. And last, don't overlook the power of automation runbooks. They can save you so much time and money.
Okay, if you remember nothing else, remember this. ARM is the original powerful JSON blueprint. Bicep is the simplified modern language we use to write it. Azure Automation is the scheduler for all your tasks. Runbooks are the actual scripts that do the work. And managed identity is the secure key that lets it all happen safely. Got it? Good.
Look, talking about this stuff is one thing, but actually doing it, that's where the real learning happens. So here's my challenge to you. Go try it. Create a simple Bicep file to deploy a storage account, and then create a little automation runbook to check on it. That's how these concepts are really going to stick.
So think about where we started. We've gone from laying bricks, one by one, to being the architect of an entire city with an automated blueprint. You now have the strategy, you have the tools to build anything you can possibly imagine in the cloud and do it with speed, with consistency, and with security. So the only question left is, what will you build first?